Bismillah Rahman Rahim. Assalamu alaikum. My name is Usama Ghaffar. My ID is 34 and my department is biotechnology. Today the topic of my presentation is atomic absorption spectroscopy, also called AES. First of all, spectroscopy. What is spectroscopy? Spectroscopy is the science that deals with the interaction of radiation with matter, atomic and molecular. The most widely used spectrometric methods are based on electromagnetic radiations, UV microwave and radio frequency. Electromagnetic radiation. A photon consists of oscillating electric field component E and an oscillating magnetic field M. In the diagram we can see E and M in different color lines, propagation direction. Absorption of radiation. When radiation passes through a layer of solid, liquid or gas, certain frequencies may be absorbed, a process in which electromagnetic energy is transferred to the sample. Foundation of the technique, the absorption of light can be promoted from lower to higher energy level. In diagram we can see this. In this diagram we can see particles from their ground state to more higher energy state are removed. What are processes by which a molecule can absorb radiation? Rotational transition. The molecule rotate about various axes, the energy of rotation being at definite energy levels so the molecules may absorb radiation. Vibrational transitional. The molecule in which they absorb a discrete amount of energy. Electronic transition. The electrons of molecule may be raised to a higher electron energy. In the diagram we can see there is a graph which is quantized in three types of internal energy. Atomic absorption spectroscopy. What is this? It is employed in 1915, used for qualitative and quantitative detection, used for determination of pressure and concentration. Concentration range is in low magnesium range. Types of samples for analysis: pharmaceutical, food, entire plant, cosmetics, and standards. Periodic table structure of AES. How does it works? We can see lamp, burner, prism of monochromator, slit. Lamp light passes from burner to the monochromator of a prism and slit to the detector and touch to the normal meter. How can we obtain the data? From the burner. The intensity of the light coming through the cathode lamp is measured. The light can be absorbed by the atoms from sample that has vaporized in the flame. The wavelength cannot remove electrons higher energy to ground state. In different ways we can absorb the data. The simple diagram for the AES. As we can see, the upper is fume extraction and fume burner. Fuel gas transfer to the flame burner and evaporate from fume extraction to the monochromator lens and photometer, which is selected to photomultiplier and digitally display our computer. These are the points we can show. The monochromator isolates the line of interest. A computer data system converts a change in intensity. We send instrument at the wavelength as the first point, and the fourth point is the element in sample will absorb same of the light. Lightyear's hollow cathode lamp and laser. Second one is laser. They are intense enough to excite atoms to higher energy levels. This allows atomic absorption and atomic fluorescence measurements in a single instrument. Atomizer. Atomizer connected to the flame, graphite, furans and hydride. Light separation, which is connected to monochromator. Note, simple dedicated atomic absorption instrument replace bandpass interference filter, detectors and photomultiplier tubes. Flame atomic Absorption spectroscopy. The technique requires a liquid sample to be aspirated, aerosolized, and mixed with combustible gases such as acetylene or acetylene nitrous oxide. The mixture is ignited in flame whose temperature ranges from 21 to 2800 degrees Celsius. Nebulizer diagram. This is the complete nebulizer working. When do we use nebulizer? As we can see in the diagram, there is a small hole in blue color nebulizer. To waste, there is a place, fuel, different ways to perform the works. Everything is present in the nebulizer. The first one is mix acetylene fuel and oxidant. The second one is a negative pressure is formed at the end of small diameter. The third one, the result in heterogeneous mixture of gases. The fourth one is the mixture flows immediately into the burner head. The five, smooth laminar flame evenly distributed along a narrow slot. The sixth one, liquid sample not flowing, the flame collects in the waste. Ignition. The process of lighting the HGAAS flame involves turning on the first fuel, then the oxidant, and then lighting flame. Instrument's auto ignition system. The flame breaks down the analyte matrix. During combustion, what happens? Atoms of the elements of interest in the sample are reduced to free. As you can see in the diagram, atomic cell and atomization. Light source when react to the atomization to the absorption and detector. Sample from the heat converted into detector. Lamp, hollow cathode lamp, consists of a cathode and an anode. The cathode is the element of interest. A large voltage across the anode with cathode will cause the inert gas to ionize. Both the inert gas and the sputtered cathode atoms will in turn to excited by collisions of each other. The light is emitted directly through the lamp window. The light can be detected and a spectrum can be determined. Fourth one is a monochromator. What is monochromator? The light passes from hydrochloric acid through the element in the sample to the monochromator. Its function is it isolates the specific light element from the other background lights and transfer it to the photomultiplier tube. In the diagram we can see this. Photomultiplier tube is before an analyze is aspirated, a measured signal is generated by the PMT as a light from HCl passes through the flame, and this causes a decrease in PMT signal that is proportional to the amount of analyte. The PMT detects the amount of reduction of the light intensity due to absorption by the analyte, and this can be directly related to the amount of elements in the sample. Signal and computer system translate it into absorption. What is photomultiplier tube? It converts light energy to electrical energy. What are the gases used for fluorescence atomic absorption spectroscopy? Different flames can be achieved using different mixture of gases depending on the desired temperature and burning velocity. Some metals from oxide do not redissociate into atoms. Some elements can convert it into high temperatures. Graphite fluorescence. Graphite fluorescence is also called electron thermal atomic absorption spectroscopy. This is the proper diagram of gas fluorescence. The first one points where the light beam we can see the source of light emits the light from wavelength, and the second one a controlled voltage is applied of 26,100. Third one, samples are deposited. In fourth, the graphite tube is permanently flushed. In fifth, the monochromator is isolates the light in PMT. Small sample, formation of stable thermal oxide, residue elements, biological samples, effective atomization difference. Mercury cold vapor. Free mercury atoms can exist at room temperature, can be analyzed using atomic absorption without employing flame and graphic fluorescence techniques at high temperature. Mercury is reduced in solution using stannous chloride or sodium hydride in closed system. This can be used in HGAAS instrument for analysis. The detection limit for mercury by this cold vapor technique is approximately 0.02 magnesium per liter. Hydride Generation Atomic Absorption Spectroscopy HGAAS. It is used for elements that are forming volatile hybrid. Is very useful in case of interference proof, poor reproducibility and poor detection limit. Now we can study many of the AAS branches like HGAAS, C and GCMS and different fluorescence atomic absorption. This is the diagram. We can see the first where hollow HCl emits the lights with the wavelength at characteristic of element of interest. In the second one, light passes from HCl through the optical cell. In third one, the monochromator isolates and lights line passing through the optical cell. The PMT detects the amount of reduction and light intensity due to absorption analysis. Sample flow in the HGAAS. As we can talk about the first one, the metal oxygenase reacts with sodium bromohydride and HCl produce a volatile hydride. The pre-elastic pump and the following reagents along with the separation of volatile hydride from the liquid. The liquid mixture flows into gas. In the optical cell, the flame is ignited by the air C2H4 into the gases. Its interferences. Any factor that affects the ground state population of the analyte element. Factors that may affect the ability of instrument can be read this parameter. Spectral interference. Due to radiation overlapping, formation of compounds do not dissociate in the flame. The most common example is calcium and strontium phosphates. Ionization of analyte reduces the signal. This is commonly happens in barium and calcium. Broadening of spectral lines in Doppler effect, Lorentz effect, quenching effect, a self-production or self-refill effect. Safety precautions of AAS. Exhaust system. Atomic absorption spectroscopy flames produce large amounts of heat of the resultant fumes and vapors may be toxic. Gas cylinder should be located outside of the laboratory. Flame solvent. The combination of flame and solvent is a hazardous situation. Always use as a solvents with high flash point. Burners. Keep burners clear and do not allow them to block. UV radiation. Hazardous. UV radiation is emitted by the flames. Hollow cathode lamps. Operate the AAS with door of flame shield closed. Thanks. In this whole topic, we can study about the atomic absorption spectroscopy, which tells about the different types: monochromator, photomultiplier tube, ignition, laser, and different also the types of AAS like HGAAS and fluorescence AAS. Different are the types of atomic absorption spectroscopy, and we can learn the structures of these and we can technique this is a technique of basically X-ray. That's all from my side. Thanks.